So we have just seen one question with respect to Venn diagram and the logical conclusion. This is another example of same model, same, everything is same, just a different version of it. So what does the statement says? Some cats are almiras. Some almira is a cupboard type. Some almiras are chairs and some chairs are tables. So again, you also try along with me. How do you represent this in a mathematical form? Some cats are almiras. So again, as I said, you have to draw that Venn diagram. So try to do along with me. You will find it easier. Some cats are almiras. So cats and almiras, they have some common component. Some almiras are chairs. Second statement is, let's say, cat. Some are chairs. So there will be some common component. But what is he saying? All chairs are tables. Again, when this comes, that means tables is a bigger diagram. All chairs are within tables. So this is tables. Okay. So this is a basic representation of your statements. But again, as we have done in the previous question, you have to combine the statements together in order to answer this. Okay. So what you have to do, just combine this. So I'll do like this. This is cats, almiras. So there is some common component. Now we're saying some chairs are almiras. So almiras and chairs will also have a common component. Next, all chairs are tables. That means chairs will be smaller, table will be bigger. So table will be somewhat bigger, like this. It has to encompass your chairs. That is the basic funda here. Your table diagram should encompass your chair diagram. Only then this statement will be true. So what do you get here? So first statement, certainly some almiras are tables. So if you see, this is almiras diagram and this is tables diagram. So you can find that there is some common component within them. This particular area. This area is common component between your almiras and tables. So you can say that certainly some almiras are tables. This is true. Because you can find a common component between your almiras diagram and a tables diagram. Next, what they are saying is some cats may not be chairs, which is also true. You can see cats diagram is this, chair diagram is here, and there is very much a possibility that some cats, which let's say in this area, will need not be chairs because chairs is far away. So this statement is also true. So just by diagram itself, you can clearly mark these statements and clearly understand which is correct and which is wrong. So you can say both statements are correct. So you can say both conclusion 1 and conclusion 2 are true. So another thing to be kept in mind is, whenever this is certainly, that statement becomes very, volatile. I mean, most likely it might be wrong, and it has to be very, in very rare cases it becomes correct. But when they say some cats may not be chairs, this is a very generic statement. This can be true. So always remember that whenever there is like some, probable, most, many, it can be correct. But when they say 100% it is correct, or it is the only thing wrong, or it's certainly everything is correct, that statements, be a little careful. In this case, obviously this is correct. But if you've seen in the previous question, both statements which say certainly are wrong. This is true for your paper 1 also. You might be knowing this tricks. I'm just reminding you that whenever there is some statement which says there is only one animal in this forest, whenever they say only, or you can say this forest has all kinds of species in it, whenever they say all or every, both these statements have a very high likelihood of being wrong. Whereas if you say there are some species in this forest, which is like a very generic, obviously it is true, any forest will have some species. Or you can say there are more than one animal in this particular forest, obviously that is also true. So that statement blindly you can put it as true, but whenever it says 100% or only one, then be a little skeptical about it. So if the statement says all cats will not be chairs, okay, that is one statement, and this says some cats may not be chairs. So there's a difference between these two. So what your question is also correct. You can see that there is no cats and chairs connection. But I'll give you another example which gives the same this thing. Okay, since you have noted down this, yeah, I think now it will be a little clear for you. So even that diagram was correct, and this diagram is also correct according to the statement. Now this says, see, now this circle and this circle has something in common between them. You have almirahs and chairs having something common, but you don't know how many chairs are within this cats category. How do I say this? Let's say there is one chair here, okay, in this particular area. Sorry, one cat. What is saying? Some cats are almirahs. Let's say there is one cat which is an almirah, which is in this location, and it also says some almirahs are chairs. So that particular almirah can also be a chair. So it means one which is a cat can be almirah, and that particular almirah can also be a chair. So there is a possibility of intersection. What I drew earlier was an extreme example where nothing is common. Let's say there is one cat which is almirah, there is another almirah which is a chair, but these need not be same. In this case, they can be same. Okay, there can be one object, because nothing prevents me from assuming that, because it says some cats are almirahs. I'll pick that almirah which is a cat, and I can say that can also be a chair. Nothing prevents me from assuming it. And since all chairs are table, that particular thing can also be a table. So that one particular object can be all these four things. That's why what he's saying, some cats may not be chairs. He's not saying all cats. If he says certainly all cats may not be chairs, that is a wrong statement. Some cats definitely, because I can pick up one example which is only a cat, which is not almirah, then this will be true. So you have to try all multiple permutation and combination for this. So that's what I said. Again, since it says some cats, it is always a likelihood that it will be true. Good that you asked this question, because I was able to explain this additional example. So like that, if you have any questions, please ask. You will get more insights into the question. Next. Yeah. This question has somewhat physics associated with it, which is the first notion when you see this question, but actually it has nothing to do with physics. It has nothing to do with physics. It is just, again, your school mathematics. Just see how we can do this. A boy plays with a ball and he drops it from a height of 1.5 meters. So represent every statement again with a figure. So he drops from here, and from the ground the height is 1.5 meters. Every time the ball hits the ground, it bounces back to attain a height 4/5 of the previous height. So what is he saying? I drop a ball, obviously it will go down and it will bounce back. But he's saying it will not bounce back to the same height from where I dropped, somewhat lesser. And how much lesser is? It will, let's say this is h. So 4/5 of h, somewhat less than h, it drops. So that is what he's saying. So it drops here, it rises, not till full height, but to some height. Again it will drop. Now, let's say this is h. Okay, so what is saying? This height will be 4/5 of h. That is 4/5 is in fractions. Anyone? No, sorry, in decimals, not in fractions. 0.8. So it rises to 0.8 h. Now again what happens? Now ball has gone down. It raises till this height. After raising again it has to fall, right? Because gravity is acting. It will fall down. But then again it will rise not to the same height again. 4/5 of the second height. Okay, so what is saying? Attain back to height of 4/5 of the previous height. Every time it will attain 4/5 of the previous height. So now 4/5 of this height is 0.8 h. But now when it drops from here to here, it will not again bounce back to 0.8 h. It will bounce back to how much? 0.8 of 0.8 h. Get this? Understand? Any doubt? I think you have a doubt. You can ask me, no problem. You seem a little doubtful. If you have any doubtful, you can ask me. You're understanding it, right? Okay. So it goes to 0.8 of 0.8 h. The second time, again the third time it goes, it will again rise to a height of 0.8 of 0.8 of 0.8 h. Okay, this is understood. So what does this entire thing become? 0.8 power n into h. Okay. So if it drops for the first time, it becomes 0.8 h. If it drops for the second time, it becomes 0.8 power 2 h, because you see it is getting multiplied every time. If it drops for the third time, it will get 0.83 h. So now this is the answer, mathematical representation for your second statement. Now what it says, the ball does not bounce further if the previous height is less than 50 centimeters. That means it keeps on dribbling, and the height gets reduced. Once it reaches, let's say, a height of 49 centimeters, which is less than 50, then it will fall and it will not rise back. That is what it means. Whenever the previous height is less than 50 centimeters, it will rise till, let's say, 47, 40, whatever is below 50, and it will drop. It will not raise back again. So what is the number of times the ball hits the ground before the bouncing stops? So you know that height at any point is 0.8 power h. Like let's say after one bounce, what is the height it attained? 0.81 into h. After two bounces, it attains 0.13. So you have to find out at what n will this less than be 50 centimeters. Okay. So 0.8 power n into h should be less than your 50 centimeters. Okay, if you can, you know h is what? 1.5 meters, that is 150 centimeters. Okay, so you know h, you know 50, you just need to find n. So this is how you go mathematically. Again, this is something very theoretical. But what you can do simply, if you don't want to go all this, what you can simply do is you write 1.5 h first, okay? Then multiply 4 by 5 into 1.5, okay? How much will you get? 0.3. So 1.2. Then you multiply 4 by 5 into 1.2, okay? This will be 4.8 by 5. How much this will be? 0.24. 0.24. This is 0.96. Yeah, 0.96. You again put 4 by 5 of your 0.96, which will be, wait, I think I have to do my maths again. $78.72. So this will be 0.768. Yeah. Now again 0.768 into 4 by 5 or 0.8, whatever is you think is good. Okay. Since you can't use calculator, this you have to do on your own in exam also. So you have to be well versed with your calculation. Don't make any errors in that. 64, 48 plus 6. 54, 56 plus 1, 61. So this comes up to 0.6144. Now again this. Don't use calculators, do as I'm doing, it will be a practice for you. So you get 0.49152. Okay. So, okay, these are the heights. So every time the height gets reduced by 0.8 times, 1.5, 1.2, this is, so the ball keeps dribbling, the height gets reduced. So this, if you want to have in a, let's say this is the ground, the ball drops on 1.5, next it raises, again falls from 1.2, it raises, again falls 0.96, it raises and falls 0.76, it raises and falls 0.61, it raises and falls 0.49, okay? That means once you have dropped it, first time it raises, goes to height of 1.2, falls, that is it touches the ground second time, raises 0.96 height only it will go, come back, touch for the third time, 0.76 it touches the ground for the fourth time, goes up 0.61, touches the ground for the fifth time, again goes and touches the ground for sixth time. Now, if you see the statement, what does it say? The ball does not bounce further if the previous height is less than 50 centimeters. So now, before touching the ground sixth time, it has only risen to 0.49 centimeters. So once it falls, since the height was less than 50 centimeters, it will not again go up. So you have to stop it here only. Okay. So if you see, it touches the ground how many times? 1, 2, 3, 4, 5, 6. 6 times it touches the ground. So your answer will be 6. You can might as well calculate 0.8 times of 0.49 and get some other height here, which is like maybe somewhat 0.12 or something you'll get. But you should not do this. The trick lies in not going further, because there is a statement here saying that ball does not, if the previous size is less than 50 centimeters. So you have to not do this. You just have to stop here. Okay. I hope it is clear. Any doubts? Oh, so answer is 6. It dribbles 6 times and stops. I mean, I think the calculation will be a little same only. Let's say 4 by 5 into 150. This will be 120. Now next 4 by 5 into 120. It will be how much? 24 times, right? 96. 4 by 5 into 96. I mean, still have to do the same multiplication, right? So you have to again 4 into 96 you have to multiply, then divided by 5. Instead what I did is convert this into 0.8, multiply 96 into 8 and put a decimal. It will be almost the same. Is there any other advantage you're getting, or like I'm unable to see anything else? So this says images of consonants of the English alphabet are observed in a mirror. What is the number of images of these which do not look like their original shapes? You understood the question? So you have to write the alphabet in English, letters in English alphabet, put a mirror image and see whether mirror image is same with the original image. But the caveat here is he says only consonants, that you should be careful. Okay, only consonants. So there are vowels and consonants. Vowels are A, E, I, O, U, and consonants are rest of them. Okay, rest of them. So when you're checking, you have to only check the consonants. So first consonant is B. This becomes like this. It's wrong. C, mirror image like this. D, mirror image like this. E, mirror image is this. F is like this. G, like this. H, if you see, it will be same. Okay. Again, I, if you see, it will be same. J will be different. Then K will be different. L will be different. M will be same again. Yeah. But you can't calculate I because it's a vowel. Even E you need not take because again it's a vowel, but anyways it doesn't count. N, yeah, like this. Then O, it is there, but again it's a vowel. P will be like this. Q will be like this. Then what you have? Q. Then okay. So how many have you got so far? 1, 2. Only 2. H and M. R, S. T again you will have same. U again you will have same. V also you will have same. W again you will have same. Yeah, mirror images will be same. U, V, W. X again you will have same. Y, if you write this kind of Y, you will definitely have. If you have Z, you will not have. So here you have 1, 2, 3, 4, 5, 6. Right. Good. So this instance of vowel, you can't count it. 1, 2, 3, 4, 5. So, and you also had H and T. No, H and M. Yeah. So these are 2, 3, 4, 5, 6, 7. Anything else? 7, right? So out of 26 alphabet, 26 letters, you have 21 consonants. Okay, out of which 7 of them are mirror images of their thing. So 21 minus 7, 14. So your answer is 14. Okay, so there are 14 consonants which are not mirror images of each other. Any doubt? This is simple. This is just writing down. It takes time, but it is simple answer. Next question quickly. A bank employee drives 10 kilometers towards south from her house and turns to her left and drives another 20 kilometers. So again, you have to represent with diagram. Another small caveat here is, it says south, it gives north-south directions as well as left-right directions. So what does it mean is, south means in general with reference to everyone. Like this is north, this is north, this is south, this is west, and this is east. Okay, this is with respect to everyone. But when I say left, means like I'm in this direction, my left becomes this. If I'm in this direction, my left becomes this. So it is based on my orientation, not with general to north, west, south. So that you have to remember. They interplay with these words. South they say, sometimes they say left. So that you have to be careful. So now let's say a bank employee starts from here, drives 10 kilometers towards south. That means downwards 10 kilometers from her house. So house is here, let's say. From here, she goes down and turns to her left. So if she goes like this, her left will be this one. Okay. And drives another 20 kilometers. Okay. She again turns left and drives 40 kilometers. So from in this direction, what is left? North. It will be this one. If she's, you can imagine yourself. You'll just see left will be north. So she will go 40 taking left. And then she turns to her right and drives another 5 kilometers. So here the right will be east. How many kilometers will she go? 10. 5, huh? Okay, another 5. She again turns to her right and drives another 30 kilometers to reach her bank. So from here, she will drive 30 kilometers right, because this will be her right, and she reaches her bank. Okay, so this is the representation of the entire statements. All the statements have been concluded in one diagram. Now you can simply answer the question, what is the shortest distance between her bank and her house? So any shortest distance between 2 points is simply the line joining the 2 points. Okay, this is again simple mathematics. The shortest between 2 points is the straight line joining 2 points. This one. Now you can see that this is 10, this is 30, this is 40. So actually she is in the horizontal line. She has just gone in a practically only a horizontal line. Though she has gone like this, you can add up. This is 30, this is 10. So this is equal to this 40. So everything is in a straight line actually. Okay. So all you need to do is simply add this distance AB. Let's say this point is C. Since this is 20, you know H and C will be, distance between HC will be 20. C and B it will be 5, because everything is in a straight line. So shortest distance will be 20 plus 5, 25. Okay, any doubt? Okay, so we'll do one thing. We'll stop today's class here. And since we have, I think some 8-9 questions we have solved. And but there are a lot more questions in CSAT paper. It will take some time. And since we are taking some good time in solving each question, we have to have multiple sessions for solving this CSAT 2021 paper. So we'll continue the rest of the questions in the next class. And if you have, again, as I said, if you have any doubts or any suggestions, maybe once you go back, you can look at the solutions. And if you have any other doubts or you are not able to understand something, you please let me know. We will rectify in the coming session. And even for those watching online also, you can put your comments or suggestions in the comment section. Then we will improve accordingly. Okay. So all the best. Thank you.